Hi everyone. In our previous video, we discussed about Stream API and we saw that how we can reduce source code of around 20 source code line. We reduced it to around 5 and achieved the same thing which our previous code was doing. So now we will dig into more details and see like what are the things that we are passing in here. Like for example, we are passing map. Within map we passed. If I go to the map, you will see we are passing a functional interface here, like we are passing function and then this. And if you go to the function, what is function is a functional interface, right? So there are various functional interfaces, but before going into the detail, we'll just see what is a functional interface and how we can use them, right? And similarly, if we talk about filter is taking a predicate. If I go to the predicate, it is also another functional interface, right? So let us start with the definition of the functional interfaces. So I've created a readme file here. Yeah. So the functional interface, by definition, functional interface can contain only one abstract method, right? So if there is an interface which has only one abstract method, that interface is known as a functional interface, right? And then it will support both lambda expressions and the method references. So if you see this stream, our previous program, so this one here, web element get text, we had two colon here. So this is known as a method reference. We are referring to this get text method of this web element interface, right? And when we are saying that we are having using an arrow, then that arrow is with the help of lambda expression. And we'll go into the more details of when to use lambda expression and when to use method reference in our this video only. So let me go to that notes again, and here we can see that, yeah, contains only one abstract method to support lambda expression and method reference. Then we can have annotation of at the rate functional interface. If you see this predicate or the previous function uh, in- interface type that we had, both had this annotation on it. So this annotation is not mandatory to have, but it will guide you in a way. Like if you are a developer and you see there is an annotation of at the rate functional interface on an interface, then you know that yeah, it already has an abstract method. So that gives you a signal that you shall not add another abstract method to it, right? So we'll have a short demo around this thing as well very soon, and we'll see why it is important to have this, but it is not compulsory to have this annotation, right? Now, if we see this, while it is not necessary, it is a good practice to mark a functional interface with this. This annotation ensures that the interface meets the criteria of having a single abstract method and serves as a documentation of the developer. Right? So as soon as a developer will try to add another abstract method, and in case there is this annotation added to the interface, we'll see a compile time error, right? That's why this is a good practice to have this particular annotation. So then how we can implement this functional interfaces? Now to implement the functional interfaces, there are two ways. Lambda expression, the one which we just discussed, like we pass the parameter, then we have an arrow sign, and then we have an expression. If the expression is a single line, we do not need a curly braces, but if the expression is going into multiple lines, we need curly braces, right? So if I go here, uh, so this one here, this is lambda expression as we just discussed, and this is the method reference. And on the left side of the arrow we have the input type, the argument, and then on the right side we have the expression, right, that is getting evaluated. And then for before going into this detail, let us start with a quick demo of functional interfaces. So I have just created a class. Let me create a fresh interface here. So I'll go to here and I'll just create an interface and I'll name it, say, functional interface, right? And now we were talking about that it is a good practice to have the annotation of functional interface. Let me add that, and then I'll have a method defined here. Let us take a void. It has no return type, and we are doing something. Do something maybe. Yeah. So do something. So we have created this abstract method. So by default, if we are not providing any keyword, it has a return type, then it is a abstract method by default. We do not need to add that keyword in interface, right? The one thing to notice here is that now we cannot add another method here, do something else, right? As soon as we do that, we get this error here that multiple non-overriding abstract method found in the interface. But the thing here is that this interfaces can have default method. So default methods are the method which are defined within the interface only, right? So the class which is going to implement the interface do not need to define these methods. So we can have something like as out and doing something else here, right? Now we have created a functional interface here. We were talking about there are two ways to implement an interface. Like if I go here, we are saying that to implement an interface, we either need a lambda expression or a method reference. So this is the interface that we have created. Now let us see how to implement this using lambda expression. So I'll use class test lambda expression, something like this, and then I'll have psvm, and here I will create a lambda expression. So in my case, I have a abstract method which returns nothing and takes no argument, right? So what I need to do is I'll have a functional interface fi equal to, then what I need is I need to just have a braces, and I'll have s out, and here we can say doing something using lambda expression, right? So what we have done here, so we have implemented this abstract method. Uh, Here you have implemented this abstract method, and here you have the reference of your interface fi. So as soon as you will call fi dot do something, what you are essentially doing is you will be having this method here doing something using lambda expression. See, you have doing something using lambda expression. So with the help of lambda expression, you are defining your behavior here, right? And when you are calling it, that behavior is being invoked. So this is the this is possible with the help of lambda expression, but again the prerequisite is that you can implement it only on the functional interface. So with the help of, you can say that with the help of lambda expression, you are getting the reference of a functional interface. How so? Because it has only one abstract method. So while runtime, Java will be able to understand, yeah, it has only one abstract method, do something. So that's why, um, like, and it takes no argument. So that's why you see blank bracket before this arrow, and it returns nothing. That's why we have s out. So if you see that, if you say, for example, I want to return something, say I want 5, so we will have a mismatch. Why? Because bad return type in lambda expression int cannot be converted to void. Here we have void, but here we have int. So what we can do is we can have int, right? And the error will not be there, right? So that's why uh, lambda expressions are only possible with the functional interfaces only. Then this was about test lambda expression. Now let us see how to use method reference. The thing is, like for lambda expression, when we use lambda expression, we are defining the behavior there. But for using the method references, the behavior shall be predefined. So how we can define the behavior of this particular abstract method? We need a class. And let me have demo class which implements our fi, right? And here what we can do is we can implement the method do something, right? So what we are doing here is s out doing something using method references. Now we need to create a new class test method reference, and what we can do is have a psvm, and then we need to create a method let me class demo, and then demo. Now talking about the method reference, again method reference is also returning the reference of your functional interface, right? Functional interface, but now with the help of this demo object we will be calling this particular method do something. Now it has the reference of your interface. What you need is fi dot do something. So if I use this now, we shall have doing something using method reference, right? So that's how we can implement the functional interfaces with the help of either lambda expressions or with the help of a method reference here, right? And if I go to the documentation again, there are this is the way defining lambda expression, this is the way of defining the method reference. So you can either define with the help of class name, then double colon method, or object double colon method. So in case class has a static method, you can just use the class name. In case you have the method as non-static, you will be using you can use the object, and then there is one more catch. This one, for instance, method of object instances where the instance is determined at runtime. At runtime means with the help of generics. For this you need some, so we will have a short glimpse within this demo only, like how to use it. So at runtime, you just need to consider that for non-static methods as well, we can use this approach class name colon colon method name whenever the instance is being determined at the runtime, right? So before demoing this part, let me quickly run through these like types of functional interfaces that mainly there are a lot of those types, but mainly these are like around predicate, supplier, consumer, or function. So to make it more uh, understandable, what I have done is I have created a snapshot of like mainly these functional interfaces can be categorized into these four parts. First one is predicate. So what is a predicate? Predicate basically it represent a boolean valued function. When we are saying boolean valued function, it means that it will return a boolean, but it will take an argument. So simply put, we can just refer to this diagram first. We predicate whenever we have argument, but we want a boolean return type, whether something we want to filter something, for example. Like if you see here in our stream API, we have checked whether our string is starting with the character f or not, right? So here we passed a string and we used a method which returns the boolean, right? So that's how a predicate works, and it will have an abstract method test. For example, if I go here filter, I go to predicate, right? I just open this and we have this predicate functional interface, and here it is mentioned that it can have any input type, argument type, right? But it will return the boolean. And as we were saying that it is under, so we I have mentioned here like it is under Java util function package, right? Here we can see Java util function and then predicate. So predicate is this. Then The next one is we have supplier. Supplier means which supplies something. It will take no argument, but it will return something, right? It is a supplier. So here you can see we have supplier, and this is the supplier, and it has a method get. It takes nothing, but it returns something, right? So it mainly in automation we can use it for generating the test data that we will see in our upcoming videos. Right now we are just having an introduction to all of these main functional interfaces, so that whenever during our demo sessions, whenever these will come into the picture, we will able to relate whether we are passing a supplier, a consumer, a functional interface, or a predicate, right? Then we have a consumer interface, and if we say about consumer, consumer will consume something, well, but it will return nothing. So it is reverse of what a supplier does. So when we are talking about consumer, consumers are normally used for logging something, right? You pass something and then you want to log something out of it, right? Or you want to change the state of some object, right? Those kind of things can be achieved with the help of consumer. So if I go to the consumer, so predicate has the test function which returns boolean and takes a parameter. Supplier, again, it will return something but it will not take something. Again, consumer, consumer will consume something but will return nothing. So for consumer I need to go to CCC. Yeah, here we have the consumer. Again, the functional interface, it accepts something but it will not return anything. Then in the end we will have the functional interface. Not functional, the name itself of that interface is function, right? So this is function. It takes argument of type t, returns argument of type r. So that's why you can see r apply tt. So mainly all of these four functions has their own abstract method. Predicate has test, supplier has get, consumer has accept, and function has apply, right? And these method signatures are as per the things that we have discussed here, right? And these types and the type of argument and the return types are all in form of generics, right? It can have any type. It can be string, integer, list, map, right? Anything can be there. So for now what I will do is I will show you a quick implementation, a quick demo of this functional interface as well. So let me go back to this particular class again, fi that I have created, and I will have class demo function type, right? I'm demoing the function type here, like how we can use it. So for that, psvm, we know that a functional interface, uh, a function will take input, and we need to define the output type as well. So for example I want the length of a string, right? So I'm saying that the type is string, input parameter type is string, and the output is integer, for example, right? And then here I'm saying get string or evaluate, something like evaluate string length, right? And now what I can do is I can use uh, 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 yeah. So simply either you can do this thing. You are saying that it will take string and it will give me the length. But thing is that we can use method reference. It is like IntelliJ is giving you the suggestion to use method reference here. Now, if you see this string is the class, right? It has a method length. Now this length method, it is a non-static method, right? But we are able to use it with the help of class name. How so? So this was the thing that we were discussing. If you remember, like if your variable, your at runtime, your variable type, your instance type is being derived, then you can use the class name to with the help of like double colon and the function name, because you are defining that the function, it will have a input type of string, and it will return something of type integer. You are letting Java know that at runtime this is going to happen. That's why you are able to use this way, like you are having a non-static method here length, and then you are using class name here. So now what I can do is I can just say eval string length. Now what method function has apply method, right? So what we can do, so just like we were doing it with the help of fi dot do something, we were passing the method name. So here what we need to do is, like, as soon as you will say eval string length dot apply, so see here, it is saying that it will take a input of string type and it will return the integer. So I can pass any string here, test string, and it will give us the length, right? But for doing this, let me put it in s out. So if I run this method now, I have an error here. Okay, yeah, eval string dot apply, and then yeah, let me rerun it. So here we have the length is 10, right? And now let us take one more example. So this one we have done with the help of method reference. Now let me do the same with the help of lambda expression. But this time what I'm saying is, like, I have integer, and I want to double evaluate evaluate double of integers, maybe something like this, right? And what I'm going to do is I pass I here and I say I cross I. That's it. And when you do it, you have defined a lambda expression, which is taking integer and which is returning integer as well. So what we can do here now is, again, s out eval double of integers and pass here your integer. The integer will be, oh sorry, eval double of integer and then apply and then pass the integer. Integer is 5, for example, right? And when you execute it, your output will be 10 and 25, right? 10 and 25. So in the same way, we can implement other functional interfaces as well. So in our further videos, we'll see that how we can implement these functional interfaces or the stream concepts in our day-to-day automation testing jobs that we do, right? So that's it for this video, guys. And in case you're liking the content that I'm making, please do like, share, and do subscribe. See you in the next video. Thank you.